Welcome to this new video. This time I want to expand on a topic of a video that I created before, and that was how to do a simple packet capture with Wireshark. And in that video, I connected to an unsecure website using HTTP, and then I show you how to get into Wireshark to find the username and password for that session over the unsecure protocol. Now, in that video, what I did is that I ran Wireshark from the same computer that I was accessing the website from. So in that case, I had Wireshark here. And if I can write Wireshark, that would be great. And then Wireshark was running and it was capturing all the traffic going through my interface. And then I accessed a website going over HTTP. And if you know a little bit about computers, I should say, you should know that HTTP is unsecure, and all the communication going over the network traffic, if it's being captured, the attacker or whoever captured that information is going to be able to read the content of the communication. So that was a proof of concept for two things. Number one, always use secure protocols, right? And number two is just to show you, hey, this is possible. But ideally, you don't want to be running Wireshark and analyzing your own traffic, even though you could do it if you're doing troubleshooting on one computer. You usually run Wireshark on other devices, depending on what you're doing. If you're doing security, if you're doing network administration, sometimes you have to analyze network traffics and you have to capture the traffic from the other devices. So in that case, what you would do, what I mentioned to you, is that you would have to do what is known as a port mirroring, or also a port span, which is the same thing. I believe the term spans come from Cisco, and mirroring is the other vendor, but it's the same concept. And basically, what you're going to be doing is that, let me come back here and forget about attacker and victim. Let's say source and destination, right? Or anything else. Uh, what you're doing here is that, let's say that you're running Wireshark on this computer, uh, because this is the computer that you use to capture traffic for troubleshooting and so on and so forth. And then the user on this computer tells you, you know what, I've been experiencing problems when accessing the network or accessing websites, and you may be on a different floor or on a different office. So what you would like to do is say, you know what, I'm gonna monitor your traffic, and then I'm gonna analyze the traffic. So what you will do is that you're gonna set up port mirroring, and all the traffic that this device is generating to do whatever it needs to do over the network. Let's say something simple to go to a website. That traffic, a copy is going to be sent to the destination. And in this case, since you have Wireshark running, then you're going to be able to analyze that traffic at a later time. As you can imagine, in this case, yes, you need access to the switch where the communication is going to take over, right? So you need access to this switch. Maybe not physical access, but you need access to it. You need administrative access to the power mirroring. So this is not a hacking thing. You need access to it. You find whatever access you need. Or depending on what you're doing, I also mentioned that you could install something right in the middle here, like a hub. Good luck with that. Or you could install a network tab, which is the same thing as a hub, but a dedicated device for that. So what I want to show you right now is this. I want to show you how to do a port mirroring, and I'm using Meraki for my example. And again, like this is a 48 port switch for my lab environment. I have just a 8 port switch, but the concept is the same. I want to show you how to do a port mirroring, send the traffic, start Wireshark, capture the traffic, analyze the traffic, and then we're going to move over to the other part of the video that is going to be a little bit more interesting in it. So let me come here, and what you see, I am running a continuous pin from my the computer that I want to capture the traffic. I'm going to call this my victim, right? So I'm running a continuous pin, and I want to see what's happening over the network from here. What I'm going to do, I'm logged in into my Meraki dashboard, and I'm going to my switch settings, and this is my lab environment, and I do know that the victim computer is connected to port number 6 on my switch. I know that, right? And I do know that the computer that has Wireshark running is connected to port number 7 on my switch. So when I connect to my console on Meraki, I'm gonna say, you know what? I'm selected port 6, and I'm gonna click on what happened here. Let me refresh this page. So port number 6, right? As you could see right here, port 1, 2, 3, 4, 5, 6. I'm gonna click on, oh, it is mirror. So let me click on that mirror because I was mirroring before. Save changes. So I'm gonna click on it, and as you could see, I have an option to mirror the port. So I'm gonna say, yes, I want to mirror this port, and the system is gonna ask me, where is your destination? And I come here and I just scroll down and I say, send all these to uh, port number 7, right? Now, port number 7, if you remember, is the attacker computer where I'm gonna have Wireshark running. So I'm gonna click create mirror, and the mirror is created. So what's happening here is that all the traffic that is being generated from my victim going out to the network is being sent to my computer. I'm going to call the attacker computer, but it doesn't help me to receive all this if there's no way for me to read it or capture it. That's why you would use a network sniffing software like Wireshark. By the way, Wireshark is not the only network sniffer, but it's the most popular network sniffer. It's been around since forever. So when you do it, let me bring this over here. As you can see, Wireshark, it's going to display the interface that I have on my computer. Let me bring this back one more time. This attacker computer has all these interfaces right here, and I have to select the interface that is connected to the switch, right? Because if I select the wrong interface, this computer also has a wireless interface. If I select the wrong interface, and the traffic from this device is being sent to this interface, and I'm doing the capture on Wireshark on the Wi-Fi interface, I'm not going to be able to see this traffic. I'm not going to capture that, right? Even though it's coming to my device. So make sure you connect to the right interface when you are running Wireshark. So let me come back here, and I'm gonna select Ethernet because I do know that that is my desired interface connected to the physical network. And what I'm going to do now, I'm just going to apply a display filter, ICMP, which is what ping uses. And as you can see right here, I'm seeing the communication from my source and the destination that is being captured. So let me stop this. Let me come over to my device and stop this. And as you can see, let me do an IP config here. And this is 172.16.5.174. I also have a Wi-Fi interface on that. This is a laptop and this is 103. But remember, I specified that I want to capture the traffic on my Ethernet port, right? Not the Wi-Fi connection on my card. So, and that is 172.16.5.174. And if I come here to Wireshark, you're going to see that 172.16.5.174 is sending continuous pings requests to 8.8.8.8.8. So I was able to capture that traffic. Now, I captured not only the ICMP traffic, I captured all the traffic, meaning that if this computer had any other connection in the background, it was browsing the web, it was doing something, I was also capturing that traffic. And that traffic, I'm going to be able to analyze it from Wireshark. Now, in the previous video, I show you that if this device, right, attempts a connection over an unsecure protocol, right, like what we tested on, like HTTP, all that information is gonna be captured by Wireshark in if that user attempted to log in uh, a site over HTTP or to log in over HTTP, that username and password is going to be captured. So we know that we did that as a proof of concept in the other video. Now, what happens if that user attempts to capture to access a secure website over HTTPS? Is that traffic gonna get captured, and I gonna be able to digest that traffic and get to the username and password? So the question has two parts and the answer has two parts. And the first part is the um, traffic gonna get captured? The answer is yes. All the traffic that is going over, as long as you are mirroring, is gonna get captured at the destination. So let me unmirror this before I forget. Now, are you gonna be able to dissect that traffic and read the content of the packets? And the answer is no, because that traffic is gonna be encrypted, right? You're not going to be able to read something unless you have the certificate to decrypt that information. So yes, you're going to be able to capture everything, but it's not gonna, you're not like the attacker is not going to be able to do anything. So in that case, if you're doing testing or if you're doing some type of serious troubleshooting or whatever else you're doing in your company, if you need to have deeper visibility into what's happening on all the activity that is going over HTTPS from this device, and you want to be able to get that information over to the attacker and see all that traffic for troubleshooting, you have to use a different tool. Wireshark is not going to be able to unencrypt the traffic to show you the raw packets. You need to use a something like the Burp Suite for that, which is an application testing utility that you could use out there for that purpose, and I can show you that right now. Because let me do this. Let me come over. Let me do the capture one more time. I wanted to keep this video under 20 minutes, but it's not gonna be possible. So again, let me just take a quick break for this. If you like this video, if you feel this information is useful, just leave a nice comment, subscribe to my channel, and just click on the like button. So let me just mirror this one more time. I'm gonna mirror this to port 7, and I'm gonna send all this, right? So that's happening. Let me come over to Wireshark one more time. I'm gonna restart. I'm not gonna save, but this time I am not going um, to have ICMP as a display filter. I'm gonna have IP source, and I'm gonna do equals 172.16.5. I said that that was 174, right? Okay, so here is my all the traffic that I'm getting from my victim computer, right? As you could see, let me, this is 174. Let me go to www tdbank.com or www.bankofamerica.com, and let me try to log in. I am a user, and I'm gonna put super secure password, right? And I'm gonna log in, and I'm gonna do the same thing here. I am a user, and then I'm gonna do super secure password. So let me stop my capture right here, and let me stop mirroring because I don't need that anymore. So what's gonna happen is that all that communication that I was doing to Bank of America and TD Bank's website, all that communication was being encrypted over TLS or HTTPS using TLS, which is HTTPS, right? So as you could see here, it is says like that the information is secure and connection is secure, and you could see the certificate right here. So that's what's going to be protecting that information. So all this traffic that I captured, this username and password, even though I was able to capture that traffic, I'm not going to be able to do anything with it because all that traffic is encrypted. Like if I come here to this, like I'm not gonna be able to read anything, right? If it were HTTP, as we saw on the other video, you'll see that you're able to see the HTTP packets in there, the codes, the post, the get, and you're gonna be able to see the username and passwords in there. And even if you applied a filter, a conversation filter, you're not going to be able to see anything. It's all encrypted, right? You're not going to be able to see anything there. Now, if you're doing testing or if you're doing something else, and then you would use another application. You would use, as I mentioned before, a Burp Suite, which is an application that you're going to be able to use it as a proxy. And then what's going to happen is that, let me come here. and erase this for 1 second. So with Burp, what you're going to be doing is that you are going to configure the browser on the victim computer, and you are going to say that you want to proxy this connection, or you want to send all this the communication from the browser, you want to send it to a proxy software running somewhere else, and it just so happens that it's running on my attacker computer. And then this proxy is going to be working as a man in the middle, and then this is going to be forwarding the request to the destination, and it's going to forward the reports, the responses to the victim. So in that case, when you do that, then you're going to be able to see all the traffic. But even when you configure the proxy, you are going to have to do something to decrypt that information if that's what you're looking for, right? Because let me show you here. Let me open up a, so I have, let me bring it over to this side. Just bear with me for 1 second. So I have the Burp Suite running here, and I am running a professional trial, but you can download the the open source version of it, or the free version, and you're going to be able to use the proxy. The professional version has more features, but for what I'm going to show you here, you could do the free version. So what I'm doing is I am receiving all that information from that target, because what I did in this case, let me bring this here. So remember that I mentioned to you that in our example, I'm going to be talking about the web browser and not all the traffic. So remember, this is the browser here. So, so, um, so what I'm doing is that on my Firefox web browser, I configure the proxy setting. So let me come down here. And what I'm saying is this: all the traffic generated from, in this case, Firefox, please use a proxy connection, and I specified the proxy IP address and the port for that session. And on my computer running Burp Suite, I also configure my proxy settings, right, on all interface, and I'm saying, you know what, accept whatever people are sending me over port 8080 or using a web browser, I'll take it. So that's what I'm doing. So when you do something like this is browser specific, meaning this, that if I use, for instance, I use Google Chrome on the same computer, right? So on this computer, my victim computer, I have Firefox, and I also have Chrome. So Firefox is the only one that is configured to use the proxy. If I use Chrome, I don't have that setting. So, hey, they're not going to apply to me. I'm going to do what I do no matter what. So if you, I don't want to say, I don't want to sound as if, like do something illegal, and because like honestly, if you monitor someone else's traffic without their authorization, that is illegal. Let's put it like that. So I'm not a lawyer. I don't know the laws. I'm not into law enforcement. I just know that that is a crime, a cyber crime. But I'm doing this for informational purposes and for analysis purposes, right? So let's keep it like that. So what I'm doing here is okay, I'm gonna send the traffic. So, but how do you, if you do that, if you send the traffic, let's say that I want to send the traffic from Chrome, right? So let me uh, configure the proxy settings for Chrome. Let me see. Let me go to performance and security. I don't even know where that setting would be. Remind me later. Okay, so on Chrome, the proxy settings, you go to the settings, then you go to system, and then you have an option here that says open your proxy, your computer's proxy settings, right? And then right from here is where you would configure the proxy settings. Setup on, and then you type the IP address of your proxy. In this case, the IP address of my proxy is 172.16.5.175, and I'm using port 8080. Okay, so I have that. I'm gonna save, and then let me come back to Chrome, and I'm gonna go to a website, cnn.com, and let me bring the Burp Suite. I have to bring that screen over to this side. Let me just come some. So just hold on for 1 second. Okay, so the way that I have set up Burp is that I have intercept on, meaning that I have to authorize every single packet before it is processed. So I'm gonna click intercept is off. Then I'm gonna come here, and that should do it. And let me come back here. So when I do that, as you could see, Google Chrome is gonna tell me, hey, listen, I have detected that the certificate of the website that I'm visiting is not authentic. And this connection may not be private. And depending on the browser, sometimes it says, there may be a man in the middle attack of something. If you pay attention to this message, it says the attacker might be trying to steal your information. And you know what? It's true. That's why I always advise people, don't connect to any network that you don't know. Or even if you connect, right? Let's not be extreme. Just like don't use sensitive information, or like even in my case, if I have my personal laptop, like to the best of my abilities, I don't connect to the networks. And if I do, I make sure that I have firewall on, that I have my permissions set correctly, that I have antivirus, that I have everything. So with that being said, is that even if you configure the browser somehow, and you're able to do a man in the middle and send all the web traffic to the attacker, the browser is going to be able to detect that, right? It's going to be able to detect, hey, listen, this is not a secure connection. It's not the intended recipient, because I'm proxying the connection through Burp Suite, and is like the browser knows that it's not CNN that I'm going to. So in that case, what you can do, right? What you can do is install the proxy certificate on the victim computer's browser, so that when you install the certificate, you don't get this message anymore, right? And then you're gonna be able to access the website. Okay, so what you need is the certificate, because otherwise you're always gonna be getting this. And guess what? If you're browsing a network and you see this message, most likely you're gonna stop whatever you're doing, right? So I would hope. So in this case, again, we're doing this for testing purposes, and I'm using the Burp Suite as my proxy. So what I need to do is get the certificate for Burp Suite and install it on this browser. I already installed it on Firefox, and as you could see, I could go to any website on Firefox and I'm not gonna get that message, right? And I don't know when you're gonna be watching this video, but hey, we have 7 hours before the government shuts down. Uh, so what I need to do is install the certificate. So for Burp, they have instruction. This is what you do. Once you connect, you come over here. You download it. It is, where is it? It is in my downloads folder. So let me come here. Uh, oh, right here. Where is my certificate managed by Chrome? Okay, so what you need to do, I don't even know what I'm having this problem here, and the video is going 31 minutes, so I want to finish this then. So what you need to do is install the certificate. I would have to go back here. Okay, import, yes, downloads, and I don't see my cert. Let me see. Oh, I don't think it's gonna take it. Let's see. Okay, it was installed successfully. So let me refresh my page, see if it works this time. Let me close and open this. Okay, so I figured it out. I was installing the certificate under the personal section of the certificates. You have to install it under the trusted root certificates. So what I did, I came over here, I searched for my cert, and then I was able to select it and install it. So once I did, you'll see that I'm able to access CNN from Google Chrome without getting that pesky message that I was getting before. So let me go back to here. So as you could see, you can send the traffic over to Burp for analysis, but if you don't have the proper cert, I mean, you're not gonna be able to decrypt anything. So, why are you doing that? So once you do it, as you could see, I have both browsers configured on this victim computer. Now, any web traffic being generated from this device uh, on these browsers that I configured are going to be proxied through Burp Suite. And what's going to happen is this. So let me do this part very quickly. I like Firefox. So let me bring Firefox back here. And what I'm going to do, I'm going to go to Bank of America. I just want to make sure that I don't have anything else open generating traffic. Let me just close this. I'm going to go to Bank of America, and I am going to type the username and password in here, right? And as you could see, I have Burp already configured. And I'm gonna turn on intercept. And I like doing that because that way I can select the traffic that I want to let through, and it's gonna be easier for the purpose of this video. So let me come here and let me just refresh this. I'm just gonna refresh. And as you could see, I'm gonna come on intercept, and I'm intercepting all these requests. That's why the page haven't refreshed. But if I do forwards, you'll see that it is refreshing. So I am going to type a username and password, and remember this case, this session is secure, right? As you could see, it is encrypted with TLS. So I'm gonna use I am a user as a user, and I'm gonna copy this, and you'll see why I'm gonna use that later. And then for password, I'm gonna type something secure and long. Okay. So, and I am going to click on sign in, but remember that request is pending. I have to approve those requests, and now I get a response. Okay. So let me concentrate on Burp Suite. Remember, this traffic that was being generated over TLS, right? So which means it is encrypted. But I do have I configure the browser to go through a proxy, and I install the proxy certificate on this browser on 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 this computer. Let me clean this up because it became kind of a mess here. So I configure the browser on this computer to go through a proxy, and I'm running Burp on this computer, which is my proxy. So the session from here is going to come here. It's going to be analyzed in Burp, and in Burp, I configured it in a way that I'm intercepting the traffic. So the traffic is being captured and analyzed, and I send that traffic out to its destination. And whatever is coming over from the destination, let me do this, right? Let's say the destination is going to say, okay, yes, I like this thing. It's going to go through Burp, and then Burp is going to send it over to the victim. That's how proxies work, right? That's why it's one of those things like, many people use proxies to stay anonymous on the web, but you don't know what's running on that proxy or using that proxy. So let me come over to Burp. And in here, I'm going to go to HTTP history. So to make this faster, I'm coming over here to the, oh, you know what? Let me just finish with intercept. Let me just finish that session. As you could see, look at everything that is happening when you connect online. So let me come here, and what I'm gonna do is, let me stop this. That was a another test that I was running before. You are going to be looking for the post method because that's what you're doing. You are sending something to the web server over HTTPS, of course, but you're using post method for that. And what I'm going to do is that I'm going to show you that if you look for that specific packet or that specific page where you typed the username and password, that information was captured. Okay, so what I'm doing here, I'm just going through the posts, and as you can see, I am filtering on that user account just to make it easy. Obviously, if you're doing a capture, you don't know what what you don't know what the user account is, but hey, I do know. So to create the video, it's easier to do it this way, just for demonstration purposes. And as you could see, I was able to capture the user from that session. Remember, the user is connecting over HTTPS from here, but I'm proxying over to Burp, right? And then this user has the certificate that Burp uses, and it trusts, then Burp sends that request, and that request comes back, and then Burp sends that request over to the victim. So all this is possible just because of the same certificate that is being used to encrypt and decrypt information is being used on the victim and the attacker. It all comes down to it. So as you could see, this is, by the way, Burp Suite is a web testing application tool. Is not, oh, let's create a tool to intercept traffic and gets user password. This is not it. This is just a tool that you can use for many, many, many different things for application testing and analysis. But it just so happens that one of the features, by dissecting the traffic and having the appropriate certificate on both locations, you're going to be able to read the traffic. So a few takeaways from here is uh, Wireshark is powerful. Burp Suite is super powerful. Just remember, when you're doing network analysis, one of the things that you have to remember is where are you is your source and destination, right? Let's talk about Wireshark for 1 second. Let's say that you have more computers, right? Let's say that you have all these computers. You could send the traffic from all these computers, mirror that, right? And send it over to this computer, right? You can mirror all these ports and send it over to that computer. But you have to remember, this computer should be able to handle the traffic from all these sources. uh, and this is like a nice simple example, but sometimes you're going to be doing this, or you're going to capture the traffic of an entire network, or you're going to capture the traffic of an entire uplink switch. So make sure that the destination is going to be able to support that traffic. That's why when you're doing like packet capture in an example like this, you're going to be running the packet capture here on the switch itself. It's easier. You're not going to have, and then you're going to do the capture on a pcap and file type, and then you're going to be able to read in a Wireshark. So your device does not have to take all the tackles coming from that capture. And number two, in Wireshark, you're going to be able to analyze only unencrypted traffic and communication on layer 2 and layer 3. But when it comes to the encryption protocols, you're not going to be able to read that traffic. For that, you would need something that's going to be able to decrypt it, like Burp Suite. But in Burp Suite, you need to make sure that you have the proper configuration for you to be able to decrypt that traffic if we're talking about HTTPS. So I hope you like this video. And this is crazy because I've never done a video that is 44 minutes long. So it seems to me that you've got a free class, right? And all I'm asking is for you to click on the like button, subscribe to my channel, and hey, leave a comment. I'm curious. Leave a comment if you are one of the few who watched the entire video or most of the video. I'm curious. But if you did, hey, thank you. I really appreciate that. And again, I'll talk to you on the next video.